So again, welcome to the channel Informal Training Solutions. So today we shall be talking about spectroscopic methods. Which are the spectroscopic methods? Of course, there are two. We have UV visible and infrared. Of course, this should be again a short presentation. What are spectroscopic methods? Of course, this involves the measurement of intensity and wavelength of radiation that is either absorbed or transmitted through a sample. Of course, when electromagnetic radiation interacts with matter, is either absorbed and some part of it may be transmitted through a sample. So what is UV visible spectroscopy? UV visible spectroscopy, this is an absorption. This is the absorption of radiation in the UV visible regions. Now the UV region is 10 to 380 nanometers, and visible is 200 to 380 to 780 nanometers. Of course, now this absorption of UV visible light causes excitation of valence electrons in both atoms and molecules from a lower to a higher energy levels. And of course, you can promote them from non-bonding to bonding electron orbitals. I'm sure we are aware that this is gamma rest, this is gamma excited state. These are the pi bonds, the pi electrons at rest, and this is the pi in the excited state, pi excited state. There's that K level which I'm sure we are aware of. What is UV visible spectroscopy? Of course, when radiation of wavelength, this is the UV region, between 200 and 700 nanometers pass through a solution or a sample of a compound containing bonding and unbonding electrons, they absorb the energy and excite from lower to higher quantum states. Of course, this absorption causes attenuation in radiation. Attenuation, we are meaning a decrease in strength of the Of the radiation. And of course, it follows Beer-Lambert's law. What is Beer-Lambert's law? Of course, with Beer-Lambert's law, it says that absorbance is directly proportional to the path length and the concentration of the absorbing species. Stated as this: A, this epsilon, delta, L, and C, where A is the absorbance, L is the path length, C is the concentration, and epsilon is a constant, or called the molar extinction coefficient. Okay. Now, what's transmittance? Of course, transmittance and absorbance. We have said that when a sample, when UV visible light passes through a sample, it's either absorbed or transmitted. But of course, transmittance is the function of incident light that is transmitted, that's not absorbed. That is not absorbed, and it's calculated as T over E over I. It can also be expressed as percentage transmittance. And of course, absorption is that one which is absorbed by this given sample. I'm sure we can calculate and then come up with this. You can pause. I'm sure from math you can come up with a proper, from using the logarithmic equations, and you can come up with this. Of course, there are calculations which I have left out. My UV visible spectrophotometer may be looking funny, but however, I'm sure you can come up with the proper one, which is properly recorded, and ensure you explain each part. Each part has to be explained: the source of light, deuterium, monochromator, what's the use of a monochromator, or the use of a slit. It's the sample, usually a cuvette, always 1 centimeter, the detector, and the recorder or the computer system. Don't worry about the wording. You can come up with better ones. I'm sure you can come up with better ones. Okay. Now, how do we calibrate the spectrophotometer? Of course, we can calibrate the absorbance scale by use of potassium dichrome solution. Of course, we always refer to reference box to get the values. Of course, you can also calibrate the wavelength scale, determining the specified wavelength maxima of 5%, version of holmium, perchlorate. Also, determination of instrumental resolution. This is controlled by the slit. You can use 0.02% resolution of toluene in hexane. Now, all these ones, the figures and what you're supposed to get in calibration are found in reference books. You're always to know how each is calibrated, by which means and which chemicals and percentages. What's the use of, where do you apply UV visible spectrophotometer? Of course, it is used to determine pK values, concentration of active ingredients, values of products from formulation. For example, in dissolution testing, you can pick up a sample at each stage, even in the execution of drugs in urine, and you calculate the concentration. Now, other terms which we have to know in UV visible spectrophotometer are the chromophore, which can be defined as a functional group or group of atoms containing electrons responsible for absorbing and usually not conjugated with other atoms. We have benzene, anthraquinone, and methyl orange. Oxochromes, now these are functional groups. These are attached to a functional group and they influence the absorption of the wavelength. Now, here we have the bathochromic shift, hyper and hypsochromic shift, either to the left or to the right or to the higher absorbing wavelength. I'm sure you have those definitions. Now, let us briefly look at infrared spectroscopy. Of course, this is also referred to as vibrational spectroscopy, and the absorption is between 0.78 to 300 nanometers. Now, of course, when a sample absorbs infrared spectroscopy, we have stretching and bending of bonds in the functional group, and each bond, it is unique. It produces a unique fingerprint, and that's why it is infrared that is used to determine the structure of, or to fingerprint the components of a solution. So when infrared radiation is absorbed through a sample, when infrared is passed through a sample, it is absorbed, causing the bond to stretch or bend, and the absorption is a characteristic of the bond. This is determined by detector and output spectra. Is that spectra in the books? The BP has its own book specifically for those spectras. And of course, infrared spectrophotometer is used to fingerprint a sample. Fingerprint means determine the bonds, the COO, the CH, and everything. So this has been a short presentation. These are other presentations in the physical chemistry. As always, thank you for listening to me. I remain Wilson. It has been brought to you by M-Pharma Training Solutions. Subscribe to my channel, M-Pharma Training Solutions. Contact us. Shall always reply, like the video, and inform a colleague.